So, welcome everyone to today's webinar, and I will share my screen with you right now, where you will see 5 new tasks added here. So, in case this is the location of them, we will open this here. In case you're trying to find these tasks, by the way, the PDF of this will be uploaded on my website in the wubbeexam.com. And for the course participants, you have it already here anyway, because that's where I basically generate the PDF from. So they're right at the very end. And for the people who would watch the recording is on YouTube. And the sample tasks will also be published here on this website in the wubbeexam.com for you to find later in case you want to revise them in your own time and practice them even further. So with the 5 tasks for the 5 topics that were not published by WU, because in mathematics you have 13 topics, therefore you have 13 tasks with 5 statements each. WU has published 8 out of 13 of them, which is very generous of them. It's very nice. They haven't done it before. Well, that's basically a new event because they didn't do this for us when we also had the open exam, unfortunately, so we were a bit lost. But now I'm very happy that they're supporting the applicants a bit more compared to the beginning of the program's launch when everything was still new. And there were 5 topics that were not published for whatever reason it might be. And then just to support you on this journey a bit further so that you have an overall estimation of how the other topics might look like or might be asked. Of course, they will change the tasks every year. So they cannot ask you the same exact thing with the same exact numbers, but they might keep the visa preparation course also. I will transcribe it into German and upload it there. It will take 1 day to translate everything and publish. Welcome. And so basically what I want to say. Yes, and here we have the 5 topics that were left out. Of course, on the exam, you cannot expect for the questions to repeat themselves what they have published, but the format might stay the same, the skills might stay similar, and so on and so forth. That's why we are training here to answer this kind of tasks. Of course, if they paraphrase it, change it to a different scenario, you still should be able to apply because you should know the math formulas very well. WU has also published the formula sheet a long time ago, actually, even before they published the tasks. But please don't count on it. It's super short. It has nothing too useful. It will not allow you to solve a task. Because let's say if you just see the formula of the discriminant, you should most likely already know it anyway. Or the formula of the product rule of 2 derivatives, again, after preparing for, I guess a month or a few months or at least a few weeks, you should also be aware of that. So it will not give you the solution to any of the tasks because, it's a lot about critical thinking. Like, they don't just give you equations to solve, they give you scenario, text-based task, where you really have to have the skill of saying what's relevant, what's given, which formulas you should use, and so on and so forth. So please don't count on the formula sheet. It's not that useful. Like, it's only like in case you forgot, let's say with the quotient rule for derivatives, you forgot what's the order of the derivatives, what goes on below, what goes out top. Of course, sure you can use it for that, but apart from that, it will not help you much. And here we have the first tasks in non-image mathematics. In my opinion, the 5 hidden tasks were a bit more difficult compared to the ones that they have actually published. Again, this is very subjective. Some tasks are easier for some people, some tasks are more difficult for other people. Every person will have a task that they don't like on an exam. Like, for some, it's financial mathematics, for some, it's derivatives. It's a different topic for each person. So all these difficulty talks are a bit subjective, but overall, let's say this is a bit more challenging and a bit more time-consuming, let's say, compared to the power function task with the farmer Ben, in my opinion, right? Of course, for some people, it might be the opposite because they might hate power functions, but nevertheless, let's discuss the tasks that are a bit maybe a lot more lengthy or a tiny bit more difficult compared to some of the other tasks that were there. And as I'm going through them and I'm explaining them to you, of course, they might seem easy because I'm explaining them. Like, you see the solutions, you're not in a 2-hour rush, you don't have like thousands of people around you. So of course, now the difficulty is also subjective to you. Like, you might think, oh, what an easy test this is. I know everything, but trust me, when you sit there, when you have time running out, you have 3 parts, you have people disturbing, the examiners working around you, checking the calculators, it feels different. So even though what seems easy now will not seem so easy on a test. But what you should also keep in mind is that every task has a solution. Every task is not rocket science. It's a relatively simple mathematics. Of course, a bit more difficult than school ones. It's like a step in between school and university, so much easier compared to university, like end of second semester or like end of first semester. But of course, a bit more difficult than in high school because they're trying also to filter out the students. So if you have any questions as we go, feel free to unmute yourself or text in the chat. And for people watching the recording, when I say something that you don't see where it comes from, it probably comes from the chat because when the recording is on, the chat isn't shown when I open it. So yeah, here we have a scenario. People will recognize this name. People like this is like real people from a study group that I've met a few times in the library. And in 2018, 8 years ago, a group of 3 friends, VG and S, I'm just making it anonymized, so to say, got 180,000 each from a study genie after he saw the efforts that they put into the WU BBE preparation in their study group session. After covering the financial mathematics topic in the course and learning about how compound interest and future value work, they decided to. So each student has 180,000 euros, and then they have decided to invest it in different, well, assets, so to say, or in different ways. So Jay deposited the money in a bank account with a yearly interest rate of 2.4%, compounding quarterly, so at the end of every 3 months. Then we invested his portion to buy a rare old bike model that is now worth 215,000. The person who does this task about knows it. And as deposited the money in an account with an interest rate of 2.1%, compounding yearly. However, after 3 years, the bank decreased the interest rate by 0.5 percentage points. And the meaning of 0.5 percentage points would be basically to subtract 0.5% from 2.1%. Whenever they see something relatively ambiguous that you might not be so sure about, because let's say increasing or decreasing by 50% is different than increasing it by 50 percentage points. In one option, you multiply by 1.5, in here you add it. So they will, with ambiguous statements, give you a little hint. Like they do really like, this is not me being generous. This is actually what they usually do in case something might be a bit unclear and debatable. So yeah, at least that's something nice. And here we will have the following statements, and on the exam you just cross the boxes with the ones that you think are correct. So here you have, let's say, 5 boxes, A, B, C, D, E. And you have to cross out, let's say, what you think are true. And leave empty what you think are false. And please don't forget to save at least 5 to 10 minutes to transfer the answers. And make sure you transfer them very, very carefully, because I've had students tell me exactly how they would solve it, tell me the correct solution, everything is great, and then they pick the opposite, what is correct. And I'm like, why did you do this? They're like, I just had like felt like it. And I was like, no, you have to be careful with this. So transferring answers is as important as getting them, because it could be really not a very pleasant mistake to know the answer, to have calculated the answer, and then just because of some rush or some stress or like mixing up the statements, to transferring them wrong. So please make sure you also save some time for that at the end of the exam or at the end of every part, depends what you want to do. You can always ask for a new answer sheet in case you mess your one up. But of course, this takes time. As you raise the hand, they you bring it. So to save time, it's ideal that you transfer the correct answers without having to change it. And there is also a trick which is also applied to you. Please read the instructions carefully. Yes, the false answer is blank. If you think something is true at first and you mark it as true, but then you know it's false, at least for WU students, if you color in a box, that would cancel out it being true and will leave it back to false in case you marked it already as true by accident. So yeah, that could be a way to fix it. But if you can't fix it this way, then you have to ask for a new answer sheet. So that's why I'm telling you, save yourself at least 10 minutes to do so. So let's see. Altogether, the study friend group increased the worth of the study reward money by more than 16%. So let's see. Here for these tasks, in these tasks where you have a long condition, it's in elementary probability tasks, in the financial mathematics tasks, it makes a bit of sense to do it at the beginning because you have to do it anyway. So when you're like in the mold, just go for it. The Johannes investment, so the investment that the present that she got from Jeannie, and you have to do the quarterly compounding. So you adjust the time period by 4. So it compounds 4 times each year, therefore 4 times 8. And you also divide by 4 to account for that. This is a compounding formula for different frequencies. And whenever it's yearly compounding, you just put 1 here and 1 here for yearly. And that's why yearly is just like 1.1 plus 0.024 to the power of 8. That's the reason behind it. But for monthly or for quarterly, it changes to 4 or to 12, it's monthly, and so on and so forth. So please know the difference between monthly compounding and quarterly compounding. Continuous compounding is also with E. For example, if like this in the E's equivalent in continuous terms is this. So be careful. Continuous. This is discrete. So yearly, for example. So you know the difference. And then this is her investment. And then S investment, you have the switch up in the interest rate. So first you have the investment. For 3 years, it was fine. And then you get some money after this time. And then that money that you got will compound at a 1.6% interest rate for the remaining 5 years. And with the bike investment, there are no calculations needed because that's just the new value. That's the future value that it appreciated to over the time. So statement A, we add up the value of all 3 investments made and compare them with the initial combined. So this is our initial amount, and these are the investments that you made minus the initial amount. So this is like the percentage rate formula. Or also called relative change formula. And you see that it changed by 18.59%, so more than 18%. And yeah, I mean, more than 16%. It's far above that. So you can say it's true, it's more than 16%. You can also not do the minus here. It's okay if you don't do the minus, then you will just get 1.1859. And you would just have to interpret this part as a percentage increase. Both ways are fine, it doesn't matter. Statement B, the effective yearly interest rate of the bike asset. Basically, if we compare it to just investing it at the bank for that percentage per year, and we say, okay, is it greater or not than 2.3%? If I'm speaking a bit slow, it's just because I've been like basically finalizing this the whole day since the morning to make sure it's perfect. That's why don't mind me if I sometimes like I say something and like I butcher it. Yeah. Here we basically try to compare, okay, this is our new value that we have. This is the initial investment. And basically, if we kind of reverse it to the bank scenario where you would invest it to account at some percent interest rate, we see, okay, we solve for I. This is a bit annoying to do. So just to see by how many percentage years it was increasing. If it increased for 8 years, we know everything apart from I. You would transfer this to the side. And you would take the root of 8 to get rid of 8. And it's the same thing as 1/8. Because the root of 8 of something, let's say x to the power of 1, is equal to x to the power of 1/8. And therefore you get I. That's a bit time-consuming to do. It gives you the exact number. A better idea, in my opinion, is to see what would happen if it were exactly 2.3% and compare it with the amount that you have, like with the new amount that it's worth now. Could you send a task sheet, please? I will upload it on the website later. I cannot send it now. It will take too much time to save it, to do everything because I'm in the middle of explanation. Because I always save it with solutions and without solutions, and you can see it on the website later. Today, late evening, or tomorrow in the morning. Later in blog. Then you would compare this one. So if it were exactly that, for 8 years, what value will it give you? So it will give you a bit more compare it to this number. So to get to exactly this amount, the interest rate here would have to be a bit lower than 2.3%. So you get the same result and the same answer for the statement. It's false, but two ways that you can use for that. Then Jay made the best investment. So out of all of the three people, her is basically worth the most. Then we see, if we compare it here, we have the value of S investment, J's investment, and V's investment. And here is the highest one out of all of them. Then S would have to deposit an additional 5,000 from his pocket at the time of the interest change after 3 years to have the same amount of money that he would have gotten if the interest rate had not been decreased and stayed the same. So as a reminder, this was the initial scenario where it was 2.1% compounding yearly, and after 3 years it dropped to 1.6%. So let's see how much he would have to invest. Two approaches. As you can see, I love plugging in numbers because it just makes your life much easier and you can see it immediately. If, let's say, we have investment and we have the promise scenario with 2.1 for all the 8 years, we get the following answer. But we know that the interest rate decreased, so for the first 3 years it was fine. Then we had to add some money and then wait the remaining 5 years to see what would happen. And if, let's say, we add exactly 5,000, then we see that the amount of money that we would get by adding 5,000 would be a bit more compared to what we actually wanted, what the goal was. So to reach this goal here, S would have to invest a bit less than 5,000 from his own pocket. Because you would need this number to go lower, and this is the only thing you can change under the conditions of the statement. A scientific approach would be, for some reason I didn't put the brackets, the bracket should be here. I will change it, of course, when I upload the solutions. And here you have the initial money for the 3 years, plus some money that the person invests, and 5 years of compounding at this rate. And we leave it on after the brackets because it's also relevant for this money because it's for 3 years it was compounding. Now you have some sum. And the compound interest works for everything that was previously there. So it also works for this part. That's why it's after the brackets. And here it also works for X that we invest additionally. And we solve for X using some mathematical rules. So going to basically, long story short, we get X being a bit like around 4,760 euros, which is less than 5,000. Therefore, the statement is false. We don't need more than 5,000. We need actually less than 5,000. Always be careful when you're doing more or less on the exam, or like exactly, please, 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 like if it's a double negation, like not this or this and that, or and, please pay attention to those. They do make a difference. You know, rereading it once for 10 seconds is worth not losing the points. Then for the final statement, E, if J had the choice between the investment she made, what the original was, here we have calculated it already, and the investment that would compound yearly, but with a slightly higher interest rate, so not 2.4%, but 2.42%, then she chose the better option. As a rule of thumb, if you have something compounding more frequently, you get a better deal because it compounds more often and gives you interest more often. That's good. But here you have an interest rate that's a bit higher. Usually, if it's only a bit higher, the more frequent one is still better. Just like intuition, let's say you don't have enough time to solve it, your intuition would say, okay, it's probably true. But sometimes it's so exact and it's a bit higher, but it's high enough to offset the frequency compounding effects. So for these things, if you have the time, please calculate because it could go either way, go both ways, either less than or more than. You never know unless you calculate. Of course, there is like you have some intuition, but still, you know, intuition and actual calculations, of course, preferably to do the calculations. So yeah, here I have, well, the initial investment, and the alternative would be the initial sum and the 2.42% interest rate for 8 years. And we compare this to finalized values. As you can see, they're very exact. So please don't rush to round. If you have the calculator, there is an answer, like it saves your previous answer usually. And if you can make it in such an order that you have the final answer as the final answer saved, and then you do what you need to do to it without basically forgetting some decimals or rounding it up, I would suggest to do it. Also, please read the calculator instructions, what each button does, what the mode button does, because some calculators have the mode button, which is really nice. How to do the, like this button, NCR, which order, because you have to get this number first, and you have to press the button, and you have to get the number here. How to do the factorial, factorial is like, you don't need it because you have this button. But basically, the ln, the root where you have to choose. Please at least dedicate one day to get used to the calculator. And if you have like the button and then you have something blue on top of it, you would have to use the second button to transfer to the second functions. To tell the calculator that you wanted to use the text options, the button options above it to perform it. So now we haven't already buy a calculator you're going to be using, and then go for it and then solve the tasks with it so you get used to it now and not on the exam day, because this will eat up time. There are 3 listed by WU. All 3 are nice. So Texas Instruments are they all do the same thing after all. They just have maybe slightly different buttons to do the thing. I will attach the list of the calculators and also have also like the study organization. While I took it with a Casio calculator, it was totally fine. Like they do more or less the same thing. So yeah, as long as it's allowed and as long as it doesn't do integrals or derivatives, or it's a graphical calculator, then you're fine. But yeah, I like mine Casio. I will send you a picture later because I'm emotionally attached to it. But the Texas Instruments are just a bit more modern. I think they're a bit more. They have a slightly nicer interface that we'll recommend. So I would say pick any of the 3 that I recommend. I think 4 or 3 are in the list. Then you have the next task, and this was one of the few tasks that were actually not text-based back in 2025. Someone asks that for question 1, it took them 10 minutes to solve it. Is it good or bad? A question like this should take you around 4 to 6 minutes to solve. But of course, some questions will take you less, some questions will take you more time. So if something takes you 3 minutes and now it takes you 8, that's fine. Don't panic. But on average, 4 to 6 minutes to have enough time for everything. Of course, everyone in the same conditions, everyone is in the same short amount of time. So everyone will unlikely have the time to do everything perfectly, but still, you should aim for 4 to 6. So it's not bad, but let's say if you do everything else faster. So here we have 2 functions. We have a line and we have a parabola, and we have function h of x. That's basically a new function from 2 old. That's different than f of x and g of x. Then you have 5 statements about it, and let's discuss them. Find the figures in the first task and compare it. Yes. Someone asks if we could have found the effective interest rate and compare them. For sure, you want. You can also compare these 2 parts together. They're really up to you. There's like some approaches are a bit like moldable a bit, customizable, but in the end they give you the same result. Then here you have the graphs of the functions f of x and g of x, and the statement says that they have more than 2 points in common with each other. So 2 intersections. More than 2. And when you imagine a parabola and a line, like realistically, it will not have more than 2. This is a statement that's a present for you. That's obviously false. You don't really have to calculate it. You can perform fancy calculations here if you want to find out how many roots exactly does it have, how many intersections, like is it 1 intersection, is it 0 intersections, or is it 2 intersections based on the discriminant. But yeah, do you really want to do it? No, because here's unnecessary because more than 2 is for sure false. But if you want, you can solve it. You can find the discriminant, and the discriminant is positive. You have 2. Also, sometimes my brain, when I think of the next thing I will write, writes it before. So if you have the same the same problem, please double check that you don't write it 0. And discriminant can be used with the function that you get by equating them to each other, because when you set them equal to each other, that's how you find the x coordinates that of the points that they have in common. For statement B, it looks scarier than it actually is. So there exist some values which are real numbers. It could be any value, could be super annoying or super unpretty numbers. That g of x is equal to a times f of x squared plus b of x f of x plus c. Long day. Then basically this, intuitively you might be thinking, okay, here I have a line, here a squared. So essentially, I will have x squared come up at some point. Something doesn't matter, but x squared will be there. Here I have f of x, and x will also come up at some point in some way, and c, some constant. So you need x squared, you need x, and you need a constant, and all of these parts are there. Just the values in B and C have to be of A, B, and C have to be found. But technically, it's possible. There is nothing that's making it impossible to do. That's the logical way of thinking, and that's the fast way to say that it's true. It's more likely to be true than false if you do it the logical way. You can also prove it if you want. There are 2 mathematical proofs of how you do it. Expressing, finding, but do you really want to do this on an exam when you have like around 1 minute per statement? No, right? I'll publish these explanations as a PDF, and I will also, well, share my screen with them, but they really are not necessary. This is just for you to see the mathematical proof and actual A, B, and C values that they exist, but not really necessary. As you can see, always try to choose the most logical and most straightforward way to solve something. Then C. The graph of the function h of x intersects the vertical axis at 6. Here, the easy way is to say, okay, h of x is the difference of them. The vertical axis intersection is basically the y-intercept. The y-intercept are the constants because x is 0 there. So you say, okay, 1 minus 5 is the y-intercept here because it has a minus here, minus here. So it is 6. This is the fast way to do it. If you want to go a slightly slower way, you can also write it out. La la la, you write them. You don't forget the minus because here the trick isn't forgetting about the minus and the minus here. That makes it plus 5. And then you get 6. So when x is 0, the y-intercept is equal to 6 of h of x, which is the difference between f and g. For statement D, here you're finding basically the minimum point of the parabola, both the x and the y coordinates of it. So global mean and x global mean and y global mean. And there are 2 ways to solve it, and let me show you both. So it's either you know that the minimum value of a parabola is calculated by using minus b over 2a in the form of the parabola like this. So this is used. And then you find it. And not forget to do the minus minus trick, which gives you a 4 in the end. And then you plug in 2 into the original value equation, and you get minus 9. You can use the first derivative. You can find the root of the first derivative to find the candidate for the minimum. You don't really have to double check if it's a minimum because you know the parabola looks like this. And the first derivative is equal here, it's 2. if you have like a line like this, of course you check if it's a minimum or if it's a maximum, or like if you have a line like, I don't know, like this, and then you have, is it a saddle point? Is it a minimum or a maximum? But here there is no other option, so you already have to do the first or the second derivative checks here. And yeah, go to -9. And we're using the first or the second derivative check. Think of what's easier to use. Second derivative means you compare the values of the second derivative, positive or negative, to see if it's concave up, mean, or concave down, max. And the first derivative, you check the signs around the root. And therefore, the function behaves like this. Therefore, it has a mean. Both approaches are valid. The first derivative approach is used when you have a superannoying function to differentiate again. Because to get the second derivative, we need to take the first derivative of the first derivative. Here you have the sum. It's the sum sign. In case you're not familiar about it, please look it up additionally. But here's basically the set is x1 plus x2. So it's the sum of the roots, because you're starting with x1 and then with x2. And these are the roots of the function. So the sum of roots of g of x is equal to 4. That's what the statement tells you. If you have a lot of numbers and you're not sure what they mean, try to like translate it into text. So in text version, what would it mean? What do they want from you? Right. Yes. Here. We can use the VS theorem. I don't like it. I am not a fan, because the moment the roots are not nice, you cannot really use it anymore, because then it's more time consuming. I will also put this on recording, so don't worry. It's going to be on my YouTube channel, so have to subscribe. Yeah, in case you would like the link to my YouTube channel, I will send it here just in case in the chat, because it's also going to be published there. While waiting for your follows. And yeah, here we are. So, and so this should be multiplication, but okay, yeah, like when you code an alpha, sometimes some things look like this. But basically, we do the discriminant way. So b squared minus 4ac. This formula you have on the formula sheet, but that's one of the only ones that like one of the few ones that you have. Then you have the roots formula, and then it's plus minus 6 over 2. And what happens? I will change it like this. But yeah, I think you know what I mean here. And then the roots are 5 and 1. And when you add 5 and minus 1, you get 4 as a result. And this is like the square root. And it says times 1 times. You can also see a graphical representation for the explanation purposes. But again, on the exam, realistically, we won't be doing that. Like this is just to show you how the points look like, the 2 points of intersection, the minimum of the parabola, and everything. But on the exam, there is no time to do it, and you don't have to do it to solve a task. It's totally fine without drawing this. The statements are not that bad. So sometimes it's worth to invest your time into something like this, but sometimes it's not. And in this case, it's not. In derivative, it's nice. In elementary probability with the tree diagrams, it's nice. But here, it doesn't matter. It doesn't make a difference. Are there any questions for this task? I assume not. And then we will move on to the polynomial functions. So recently there was a Formula One because we were traveling to a friend's house for some barbecue on the long weekend. And then one of our friends had like he was driving, he was like, I will have only one condition. I have to have access to a TV to watch Formula One. And we were like, sure, we have it, like you can watch the TV, and that was kind of funny. That's why I kind of remember it. But it was, I think, recently held or something like this. And yeah, this is the car setups, new words for me. Didn't know them before. And then you have over 150-second performance trial. Then the velocity of one of them chases A. I hope I pronounced it correctly. It's this function with all these small numbers. And then here you have the time in the table version for chases B. You have 10-second intervals, and you see how the distance was changing in those seconds. So at time 0 it was 0, time 10 it was 90, time 20 it was 200, and so on and so forth. And I know how funny it sounds to read this for Formula One car. Unfortunately, when I was making this task, I made sure that the numbers just look nice and they calculate nicely. But I didn't really double check with the Formula car speeds. I know it's more than that. But let's ignore this little thing. What's important is the math part, right? It doesn't matter. What's important is the math solution here and how you would reach it. Here, we would, to get the average velocity, we take the final time and the final distance covered. We don't care about the points, we care about the final result. And we have the total distance, we have the time. I hope you remember that we divide the distance by time to get the speed. And this is velocity in meters per second. And then to convert it to kilometers, we times it by 3.6. If you forgot that you times it by 3.6, you can also do it like this way. Because if you want to go into kilometers, you divide by 1,000. And to go from seconds to an hour, you divide by 60 to go to minutes and 60 to go to hours. That's how you adjust. That's identical to 3.6 if you do the calculation. Up to you. You can do it this way, you can do it this way. You just if you forget this, you can also just do it from scratch. So as you can see, the car is very fast. It needs more fine-tuning, I would say. And then the minimum acceleration of chases A is reached within the first 70 seconds of the trial. So before t was 70, we take the velocity function. Then here we want acceleration. So we take the second derivative of velocity because the second derivative of the distance time function. So it's the first derivative of velocity. Then we do a very simple differentiation calculation here. And then it's a quadratic opening upwards. Like this. Oh, sorry. And then this is the vertex. And then here you can find the point with the formula we have from later. It's a bit faster to do it this way because you have all the points here. So it's 75 seconds. It's the minimum point. And you can also do it with the first derivative if you want. And then check. But both approaches are fine. I think just the vertex one takes you a bit not that long. Because then to find the minimum acceleration, you would take the first derivative of acceleration here. So you would do the loop again, basically what you have to do here. This is, I think, a bit faster. Then for statement C, the velocity profile of chases B based on interval slopes has exactly one local maximum. Here, unfortunately, you have to do the calculations for each point. I know it's annoying, but don't hate the players, hate the game. They know that you have a little bit of time and they still give you something like this. So what can I say? Then here you have a table, you have the time interval, you have the change in the distance. And then you have the average velocity being the division of that. Because it's plus 10 seconds each time. So it's plus 10, plus 10, as you move forward. And then you see how much it changed in between 0 and 1, 0 and 10, 10 and 20. So it's like plus 10 seconds, yeah, like this basically. And then from the table, we can see how the distance changed. Here. So here the change is 90 between, so basically you would have to use this formula. So F2 minus F1, so the average rate of change formula, because here you don't have anything better to do. Like here you're only working with what you have because you can't do anything else here. So for example, for this point, you would do, it's always 10 on the denominator, that's a good sign. At least something, and then it's 200 minus 90, for example, that's how you do it. From 10 to 20, and from 90 to 200. That's like an example for this point, and you do it for every point. And then you divide. But they're not always increasing. They're like relative, like on average, sometimes it increases faster, sometimes it increases slower. Here it's slowing down. So here you have a maximum here. And only one. Because they're always going up here and then down from there. It goes like this. No, you cannot do that because those are changed every 10 seconds and the change in the distance is different each time. It's not a constant. It's not like it's not, you cannot do that. It takes less time, but it's not possible. It's not, you will not get the right answer by doing that. You can also draw it like this if you want. Like this, if it helps. Or on the graph, you want to connect the points together. Because sometimes maybe the graph can look like this. And has like, let's say, a min here, and a local min here, and a local max here, and let's say a local max here. But here we just have a max. Because the reason you divide it, here you have the time, here you have the distance, it's not the velocity. So to get as close as you can to velocity, you would do the speed formula. Because velocity and speed are very similar in physics. The only difference is like velocity has a direction, speed doesn't. That's the only difference. And here we don't really care about the direction. So velocity and speed, use them interchangeably here. And then we basically get like velocity here, like speed is equal to the distance covered by the time. And here the distance covered is like plus 100 and the time is plus 10 seconds. That's the reason for the division. And I'll just taking them straight away. Because the distance was always increasing, but it wasn't always increasing at the same rate or the same speed. Then chases A is accelerating, so losing the speed at the timestamp t is equal to 90 seconds. Let's see. That's true. So we have the acceleration function. We found it from the later statements. That's why on the exam, when you're doing the notes, make them relatively neat because you might be coming back to what you have here in the later statements. You plug in 90 to see how acceleration is. If it is a negative value of the function, that means the acceleration is deaccelerating, so it's losing the speed. Because when you have negative acceleration, it means you're kind of letting go of the gas pedal, so to say. And statement E, the highest average velocity for chases B was achieved during the 10-second window starting at t80. The 10-second window starting at t80 would be 80 to 90. So we're checking if this was the highest average velocity here. Let's see. And here we can see that the highest average was from 60 to 70, actually, not from 80 to 90, because here you have velocity, average velocity of 22, and not this one. So therefore, it is false. What do you mean draft sheets? I mean, you can always ask them for more. You have blank papers, but you can ask them for more if you run out. But I think they should give you plenty. But you can also draw on the exam paper as well, so should be fine. Then here you have the pre-last task, because we have 5 to discuss, and this is the differentiation single variable systematization. Looks scary, looks like, oh no, what am I gonna do? But it's actually not as bad as you might say. Like some things that look super scary are actually super logical, and like they're kind of, you know, like have false friends when something looks easy but it's difficult. Here's the opposite of that. Here it looks difficult, but it's actually easy. So on the exam, please make sure you don't overcomplicate things in your mind, because some things are not complicated. Of course, there is a fine line that you walk when you say, okay, this is super easy, therefore I will miss out this detail, which actually was the important one that would have changed the answer. But sometimes not going all in your head about a task that's actually relatively nice is also saving you from like time wasted on something that's actually not that bad. So here you have the revenue function, you have the cost function, and you also have the time in minutes to produce a batch of volume X. So here it's a piecewise function, meaning that for a unit below 15 or equal to 15, this is the function for the time. So time is a separate function. Like it looks like it, oh no, it's going to make it so complicated, but this is unit wise and this is time wise. So it's not going to really interfere with these two. If they decide to make it somehow interfere, it's going to be stated in a slightly different way. It's going to be kind of clear that this would somehow, like this would be here. Here, and for the units over 15, or 15,000 units, you have this function. Then let's see what happens to revenue, profit. Sometimes they also have like little explanations here and there, which are also nice. So I also include them in the task set here. And let's see. So revenue is maximized at a volume greater than 25,000 units. So here they're asking not for the revenue, but for the units of, not for the maximum revenue, but for the maximum units. So always be careful what they're asking. We have the revenue function, quadratic downwards, the maximum. So whatever is the root of the first derivative is going to be the maximum. You can also do the vertex approach, is just a bit faster, a tiny bit faster, not that much, but you can also do this approach. So minus 10x plus 200 is equal to 0. 10x is equal to 200. X is equal to 20. And there are 30 math tasks, as there is one task per topic. One second, I'm going to change. Okay. Then here the profit. So here we just take the difference between the profit. For the profit, we take the difference between the revenue and costs. These are the functions from the conditions. Then you get the profit function. We take the derivative because here you actually have to do it. And then, yeah, we see if 30 is the maximum. And here you might be wondering, but Maria, we cannot solve cubic equations. Oh no, what do we do? But here to check if it's a maximum or not, it's enough for you to know that the first derivative is equal. So for it to be a maximum, the first order condition would be this. Oh, let us. Is it true or not? This is like the first thing, the bare minimum it has to meet. And it doesn't meet that. So when you plug in 13 to the first derivative equation, you get minus 12,000 and so on and so forth. Therefore, it is not a critical point, so it can't have the potential to be maximum. So yeah, things are difficult, but not that difficult. Yes, writing right on the paper is fine. What you cannot do is you can't write on the answer sheet, because on the answer sheet you only cross. It has to be the neatest thing you submit, because that's the only thing that's going to be checked. Then the marginal costs, so the derivative of cost with respect to volume at point x0, are approximately equal to this. So let's see. Yeah, they're equal. This is exactly the same. Marginal cost just means the derivative. Yeah. Marginal revenue also means the derivative. And marginal cost would be the cost of producing one more unit after the one that you're standing at. And so the marginal revenue, it's the revenue of selling one more unit, not the total units, but one more compared to where you're at now. If you're selling 20 units, what's the revenue of selling the 21st unit? That's why we're using the first derivative, because we're comparing the points in time, not the interval of some units like 10 to 20, but at point. And then here, for statement D, here we are using the piecewise function. So the slope of the tangent line, which means that the first derivative, right? This is the identical of it. So if you have a function and you have the slope of the tangent line, it's the value of the first derivative at that point in time. It's equal to the slope. And at point 12 is given point -. So we know that here we have one condition here with 12 and the other condition here with 20. By knowing that, we proceed to find the first derivatives of these. So we find the first derivative here, the first derivative here, and compare it by plugging in 20 and 12. Here, the first derivative for this part, for the minus or equal to 15, it is, actually the system like should go in order, but yeah, just the it's fine. Like I will reform like it's like this. But I'll reform it when I upload them, because here I can comment on them. And then here, for 12 is less than 15, you're applying this, and here you're using the derivative with the chain rule. So here you take the derivative, so 3x. So basically you have it here. And this would be the product rule of the two functions. Which would eventually simplify down to this. So you take the first derivative of the first function, leaving the second one untouched, plus the first one untouched times the derivative of the second function. And here you have the chain rule, because it's not e to the power of x anymore, it's e to the power of a function. So use the chain rule, you take the derivative of the outside function first, so e to the power of something is e to the power of something. And then you take the derivative of that something that's there instead of x. And when you simplify it down, you take 3 out as the common multiplier. Here, you take e out as a common multiplier, and that's why this is 1, because this is exactly the same. If you were to open up the brackets, and you have minus 0.4x, because here you have what's left is x and this part to get back to the original. Yeah, then you plug in 12 and you look at the value. For x more than 20, you have the first derivative of the other condition. And the first derivative here, you just have, this is a constant, and constants disappear in differentiation. So it basically becomes 0. You also have the rule in the formula should be divided by WU, but again, you should know this. And the first derivative of this is just 0.015. And then we compare, So this is obviously more than this. Therefore, the slope is greater when x is equal to 12. Therefore, the statement is true. Then for statement E, if for now for A, the revenue function satisfies conditions, so at point 10, so this is kind of the initial point in the interval, what we're starting with, they have the same value. Then we know that the first derivative of x for the firm A is more than the first derivative of the revenue of the original firm that we have in the conditions. Then we know that the firm A revenue will be greater at point 12 than at the original firm. A logical approach, yes. If they start with the same value, this is faster increase over this time interval. So it increases faster in this 10 to 15, 10 is the starting point. Yeah, if something is increasing faster and they start with the initial value at point 10, then it's going to have a larger value overall. That's a very easy true statement. If you want to make the statement hard and you want to do the proper mathematical approach, you can if you want. I'll show you how, but again, not necessary. You take the difference between the original function and the firm A function. You know that the difference at point 10, when x is 10 is equal to 0. You know that this is the case from the conditions of the task. Therefore, if you rewrite it, it's going to be greater. Basically, you can put this to the side. It's going to be this thing is greater than 0. And then the difference is increasing because this one is growing faster than this one. And then for any x greater than 10, then you know that 12 is greater than 10. And yeah. So the difference between the two functions is more than the initial value. Therefore, the firm A revenue at point 12 is greater than the original firm's revenue at point 12. Again, you can do it this way. You don't have to do it this way. Do you have any questions on these tasks? Then if not, we are coming towards the last task. So this webinar will take approximately 1.5 hours. So here you have while studying the WU, students choose a primary transportation method to get to campus. And the preferences change depending how close they live to campus. So 55% of students live near campus. So group 1, like Milestone did similar. This is unfortunately not sponsored. And the remaining 45% live further away. So among students who live near campus, 30% use a bicycle, 25% use public transport, and the rest walk. Then you have in the overall student population, 40% of the students use public transport, and 30% use a bicycle. And then the university is running like a green campus initiative and is continuing targeting specific student groups for different subsidies, ads, and so on and so forth. You know, because Vienna is quite active with environmental friendliness, also the recycling bins and everything. So yeah, it's a big deal here. Then here we basically have 5 statements, and what is ideal that you do is that you draw something like this, a tree diagram with the solutions. Because once you draw this, the rest of the statements are solved automatically without much thought. Takes a bit of time, takes also me a bit of time to do this, but worth it. Or you can go with the state because if you go with the statement and try to do them one by one, there is a possibility of confusing very easily because here you have a mixture of condition, probabilities, and intersections. For example, this level, this is level 2, this is level 1, this is level 3. Here, level 2 are conditional probabilities. So like how likely are you to ride a bicycle if we know that you live in group 1? So yeah. But the level 3 are the intersections. So here you have if you are randomly assigned to group 1 and the probability that you randomly ride the bicycle. This would be the multiplication of those two. Sometimes you know one, sometimes you know the other, and depending what you know, you can get the other things. You also know the overall distribution. You know that 40% use public transportation in general, all the students, and 30% use a bicycle, and the rest walk, so 30%. This is all from the conditions of the task. Let's say in physics, when you were learning it in school, sometimes you would have written out the given part before solving it, which is actually a good trick, because when you write this out, you can see what you have, and then you can basically fill out the tree diagram, well, accordingly. And you have to be careful what adds up to 1. So for example, these, like this level adds up to 1. This level here and this level here adds up to 1. And this all together has to add up to 1 because these are all the students that we have. And this also adds up to 1. Magic. When you know the intersections, you can find the missing pieces here for the faraway group because you don't have them given in the text. You know how many people in total walk? That's why you do, say, 30 students. I'm like, 3,000 students because like these are numbers are so ugly, but well, what can we do? And then like basically 0.3. You can also put like a number like 30 students, 40 students, and like 30 students if it helps. But here with the ugly numbers, it might not be like the best interpretation with like humans because you can't really have 0.0, like 5.25 humans, but you can just use a higher number like 10,000 students, like 1,000 students, for example. And then here, when you find out the intersection, because you know that 40% of all the students use public transport, you know this many are here, therefore the difference of that has to be here. Then when you know the intersection, you can find the conditional probabilities. Because to find the conditional probability, so PAB, that's the same thing as P and B on the top with the sign, with the U sign as well, doesn't matter, and PB. So the upper part is the intersection that you now found out, and the lower part is the condition that you know has happened, which is the faraway group that we chose. This kind of, yeah. You also have the bias formula that you can use this, but here you don't really use it because the intersection is given to you directly. That's why you don't need this formula, because you could also use this one. I mean, it doesn't matter, it's the same. Because PA is basically just the public. Yeah. It will give you the same result. So yeah, it's just a bit easier to do it this way. After doing all of this, you can move on to the statements, and then you can solve them pretty quickly. So for the first statement, you have to maximize the probability that the student reached by the initiative is the public transport user. You should target group 2. Logically, it sounds correct because if they live far away, they logically use more public transport. But again, if you have the time, please calculate, because it can maybe the other way around. So what is the probability of using public transport knowing that you're in group 1, the closed group, or in group 2, the far away group? And you can see it from the table. Here it's given with 0.25. And here you're calculating it here, this part, B. So group B has a high probability, so it should be targeted. This is how the algorithm behind the ads that we receive in Insta work. And then the probability that the randomly chosen student lives near campus and uses a bicycle. So here both are random. Being near campus is random and using a bicycle is random. So here we have a lovely task. We just multiply the probabilities being close, 0.55, and the probability of using a bike in general, which is 0.3 here. Or you can just go here in the intersection, same answer. Then for statement C, less than 3% of all the students are such students that live far away from campus and walk to the university. So here we have group 2 and walk because these are the students. This is the intersection, far away and walking. That's why we are multiplying the probabilities. So you have the far away, 0.45 here from the table. And you have the walking group, this one. So you get 5.21, 25%. So here it's either you're doing this times this. So being in group 2 times walking and being in group 2 because they are dependent probabilities. Therefore, you cannot just because like here, okay, actually you don't look here. Like for this part, you don't look here, not correct, because they are dependent. Because like this part you can use for independent events. Since these depend on each other, you would use this probability given A. And we have the given, so walking knowing you're in group 2. Or just looking here directly because we kind of found this one first. Anyway, before finding C. Then the last one was the probability for, not the last one, but statement B. So a student who uses public transport decides to purchase a monthly digital pass upon seeing a notification with the probability of 0.65. And of course, if you don't use the public transport, do not really care, you will not buy a digital pass anyway. The probability that the random list of students decides to buy the digital pass is more than 0.25 if there is no additional targeting taking place. So we have the following probability. So probability of buying is essentially the probability of using public transport, which we know is 0.4 from the conditions of the task here. And 0.65 is the probability of buying, knowing that you have the public transport given to you in text. Yeah, and it's slightly more than that. Then the last statement, it's condition probability, but reversed. So here, the probability that a randomly chosen student who uses a bicycle, so what is given, so in this case, AB, the given one, is the bicycle. And what we want to find out is the far away. So we phrase it in this way. Group 2 giving bicycle. So the far away group giving that you have a bicycle. The bicycle users, there are 30% of them from this part. And then basically the probability, the upper part, the probability of group 2 and riding a bicycle would be here. So the probability of group 2 is 0.45. And the probability of riding, one second, where is it? I'll just rewrite it because there's so many letters now. So I'll just write it here. So be far away times the probability of this. So the reverse part, riding a bicycle, knowing that you're far away. Like this. This is using the bias theorem, pretty useful here. And we have the following. Here, the bicycle, probability far away is 0.45. And the probability of riding a bicycle, knowing that you're far away. This would be this part. This is the conditional one. And we have found it here by finding the intersection first. there is any chance on the real exam. So these are inspired by the difficulty of 2025. So they might be the same, might be a bit easier, might be a bit harder, but usually they make them harder. Like I have not really seen WU go back and reverse with difficulty. So either more or less the same or a tiny bit more difficult. Or a completely different, like for example, like they really have a choice of making a graph or an equation or a text. For some people, a graph is easier than text. Therefore, they make more graphs than text. For some people, it's going to be easier. Of course, yeah. But this is more or less what you would have expected in 2025. And of course, in 2026, we can change things up. But yeah, this is the most recent reference that we have. And I was holding back so much because like from the feedback, of course, I tried to make them as close to the difficulty that actually was. But I was like, I know how to make it more difficult. Like I was like holding back so much from some statements, like not to make them more difficult. So yeah, because usually in the course, for example, that I have the tasks, my students have noticed that I do make tasks a little difficult because, you know, the time it was out, you have more time here, less stress here. Therefore, you solve a tiny bit more difficult task. In the same time, you will solve a tiny bit easier task in the same time on the exam under all the stress and pressure. Do you have any additional questions?
No.
Perfect. I'll leave some people a few more minutes in the chat. No, WU cannot ask tasks on good and official list. It's not allowed because they publish the list way in advance, and there is one task per topic. And it's very much possible to, for WiSo, it's also 13 this year because now the topic list is the same for BBE and for WiSo. And for economics and English, there are 10 tasks for economics and 10 tasks for English out of all the previous years. And then I don't think all 3,900 people will show up, but the majority of them will. In our year, it was around 80% show up rate. So let's say even if 3,000 people go, it's still quite a lot. And Messevin is a very big building, so there is enough space for everyone. Don't worry. We will take care of it because for WiSo, there's like 6,000 something. So if they can hold 6,000 in the morning for WiSo, they don't really have a problem with hosting around like 3 something thousand students for BBE. Also, for people who are new here and who are done with their exam preparation and who would like to test if they're on the right path or not, and who would like to experience the exam stress before, what I also have for like more towards the end of the preparation offer is the exam simulation. And I will also be offering it offline in my office in Vienna, so close to Schwedenplatz, very convenient to get to, in case you would like to try and take it online or offline and see how it goes for you and double check how well you do time-wise, stress-wise with people around you or online at home. Please let me know because of the online thing, it can be done anytime if you want. And the offline, you would have to let me know in advance because I'm hosting them on the 27th and the 29th of June. So in case you would want to join those, please let me know and I will send you all the details. Because this would be the final stage that you would do. I mean, here, yes. So basically, depending on where, yes, there's one each task for one topic, but of course, differentiation can come up in other topics as well. Yes, every topic shows up once, exactly. You can't really have something that show up. And yes, so if you are preparing so far and you've done most of the revision for economics, for mathematics, then it's helpful to do a mock test because then you see where you stand. Are you on the right path? Do you need to revise anything more? Do you need to focus on this task more, on this task more? And yeah, so I'm offering them online and offline in case you're interested because I want to announce it, but I also announced it a bit earlier here for the earlier spots, you know, like as a little bonus for people who stayed until late and the 29th. Please text me guys. And you can do it by contacting me on Instagram here. And then yeah. With the English part, WU hasn't really posted any questions, and they are just a reading comprehension exercise and some vocabulary and grammar tasks. I think in some videos, I have a video about English part in my shorts on YouTube and on Instagram as well. And I've put up samples there. I can also make a blog post if you would like. For example, what I'm publishing here. Yeah, I'll make it a bit later on the blog post because English part, it is still important. It weighs the least. It weighs, as of the previous years, 21%. Of course, I can change it up. But here you have the blog part where I'll publish something, but on like, yeah. So for the English part, what you should be preparing is reading comprehension and doing it in time and fast, because there you need to be quite quick to have enough time for the math part. And then you have vocabulary and grammar questions, which are a bit random. So improving your vocabulary, academic one, especially in grammar in all the levels, conditionals, tenses, all that stuff, adverbs, adjectives, is very helpful to minimize the chance of not knowing something. Because they even asked an idiom on one of the years. So yeah. For reading comprehension, I would recommend Business English Cambridge. These are the best ones. Business English Cambridge reading comprehensions are the closest you get with the vocabulary because IELTS and TOEFL are a bit different. And last year it was 86.8. I wrote it here. Again, for every question I have an answer. This is, yeah. But of course, this score will likely go down because of negative point system and fair knowledge conditions for everyone, and probably not everyone showing up in the end. But still, let's aim for a bit around 85% just in case. But yeah, should go lower realistically, but let's see. On each section, I recommend to spend around 1 hour in total on English and econ, even less if you can. And then at least an hour in mathematics because that's when you need the most time. But also don't forget about 5 to 10 minutes. You need to transfer the answers to the answer sheet and have enough time to do it carefully. So yeah, time will go by very fast. For the economics part, it's not enough to just read it, but if you understand it, summarize it, and then you make neat lists about the formulas, what they really mean, and so on and so forth. So you do active learning, yes, but just reading, no, don't do that, please. It's too good of a part to gamble with because all the questions in the econ part are based on the book. So make sure you know it very well. And what percentage of the students get in the course from the waiting list? So the wait list, that's the, for example, last year the wait list was very close actually. It was 255th spot, I think that was. So like already here it's not accepted. So it don't count on the wait list too much. And you do usually can come up, yes, depends. Gaussian distribution, no. Gaussian distribution is from the previous years. They changed it to logic and it's an extra topic in my course because some people need it for other exams that they're taking. But Gaussian distribution has been changed since 2023. It's not a topic anymore. And then Newton and Integral are usually what comes up, but again could be changed to just normal compounding interest. It's really up to them what they include because anything from the topic they can include. The waitlist is like I think every year between like 255th until like 270 something. So yeah, not that much leeway there, I would say. And also it was very stressful to be on the waitlist last year because it actually took them, I think, around 1 month to announce the final results. So yeah. Because usually they did fast, but that year they took their time. Yes, if some people get accepted but they say no, you get a spot from the waitlist. If you're waitlist, let's say if you're like 250 and people say no before you, you get in. And so far, everyone who was waitlisted that I know of got in from the waitlist because it was always the same spot. Let's say there was like 4 or 5 students with the same spot on the same, like they were all waitlisted and they all got in. So yeah, that's how it worked last year. But this year with the negative point system, it's very statistically almost impossible for someone to have the same exact points. That's why it should be more kind of spread out. You shouldn't have like 4 people in the same spot like it was last year's, because last year's, if like 3 or more people had the same spot, they just took everyone. They didn't do anything about it, which was nice of them, I would say. The same, they take both people in. So far in the previous years, both people who had, or 3 people or 4 people who had the same score, they all got in. So they took in a bit more people because I think they pretty much knew that because of visa issues, not everyone will show up. That's why, yeah. Very nice solution, yes. So, any more questions? If not, feel free to reach out to me via one of the websites. So you have the contact form here, you have the contact form here, you have my Instagram as well. You're welcome. And in case you want to check it out. Yeah, I think at this point I'm so tired I cannot even spell. Maria Tici, or email if you don't wanna use Instagram and you wanna, like if you have it deleted for the exam prep time. Yes, yes, typing. Most people graduate. So most people who attend to BBE actually graduate. It's very easy to do so in 3 years. It's very hard to get kicked out. It's almost impossible to get kicked out because you have retakes and 4 to 5 tries per course that you take, and everyone graduates. It's the WiSo, like the WiSo is a bit of a bigger problem like the German bachelors, where they have like 2,730 spots. That's where people don't get enough spots for the courses, or like the STEOP exams, so the introductory exams are a bit hard, and some people pass them from the 3rd or the 4th try. That's where the kind of it changes a bit, and some people drop out to go to like a Fachhochschule to finish in 3 years and forget. But yeah, in BB, it's not that hard to pass. So I would say for WiSo, it's a bit easier to get in, but a bit harder to study. For BB, it's much harder to get in, but a bit easier to study in the end. So you choose basically when you suffer. Say you suffer either way, but you choose when. Yeah, that's because as the years go by, every program has more and more applicants. Also in Univin, more and more programs have more applicants. Like it's a trend that I see. You get more and more people applying. So yeah, competition is growing each year. Then thank you for all the questions. Thank you for staying until the end. And I will publish everything these days, today or tomorrow, on YouTube, on my blog. And if you have any additional questions, feel free to reach out to me in any way that you have recently mentioned. So thank you and ciao, ciao. Best of luck on the exam day. Bye. Bye
Bye,
bye.
thank you so much.
Welcome. Bye bye. Thank you. Ciao, ciao.